So see, osmosis means the solvent moves lower concentration to higher concentration side. So here, you know the meaning of solute, solvent, and solution. Okay, solvent means which one is dissolved. That is solvent. Solute, which is dissolved. Solution, when we combine solute and solvent, it forms the solution. Okay, so here osmosis. Osmosis means we have first, what is the definition of osmosis? Okay, so osmosis, when two compartments containing solutions of different concentrations are separated by a semi-permeable membrane. Semi-permeable membrane. The solvent moves from lower concentration to higher concentration. Okay, so for osmosis, an example is dry grapes, kismis. Okay, so dry grapes soaked in a container of water. The concentration of the minerals inside the grapes is higher than the concentration of the minerals in the container of the water. When we soak for a few hours, we see that grapes are swollen. Okay, so you have to soak kismis or dry grapes, you have to soak into the water container. Okay, after some time, what do you observe? The dry kismis turns into swollen. Okay, it means some swelling is there. So why does this happen? Why does this happen? The dry kismis turns into swollen, right? Swollen grapes. Why does this happen? So the water from the compartment moves into the grapes. The water from the compartment moves into the grapes. That is the skin of grape, act as a semi-permeable membrane, and the water moves from lower concentration side to higher concentration side. Okay, so here when you soak the grapes into the water, after some time the dry kismis turns into swollen grape. Okay, why does this happen? So the water moves lower concentration to higher concentration. So here the grape skin acts like a semi-permeable membrane. Okay, so semi-permeable membrane. These semi-permeable membrane, it allows only solvent. Okay, the semi-permeable membrane, it allows only solvent. Okay, so that is about osmosis. Now reverse osmosis. Okay, so this higher concentration, this is a natural process, and this happens with the minimum pressure, which call it as osmotic pressure. So it is this process is naturally occurred. Okay, so that pressure is called osmotic pressure. Listen carefully. After completion of the session, I will ask questions. If you say the answer, I will give the present. Okay, remember. And next one is reverse osmosis. And next one is reverse osmosis. Okay. So reverse osmosis, the compartment with the, okay, you see, this is, just remember, assume this is the green color and this is a blue color. So this is a sea water. Okay, sea water turns into pure water. Okay, sea water turns into pure water. How? Where do you observe these type of conversions? Anybody? Sea water or any different types of water converts into pure water. Every day we are observe that, and it is very familiar with us. This type of process. Okay, where do you observe this one? RO water. Yes, very good. Abhigna, water purifier. Yes, water purifier we can observe. So you can take any different kinds of water. After some time, it turns into the pure water, right? So the compartment is brackish water, which is of higher concentration. So brackish water is nothing but sea water or saline water or okay, saline water. So these water which is of higher concentration, I mean the sea water contains higher concentration in the compartment, down compartment. You can observe this one. So this is pure water, whether lower concentration. The sea water contains higher concentration and pure water contains lower concentration. So from this diagram, what do you observe? So from this explanation, so this higher concentration level, the solvent moves higher concentration to moves to lower concentration. Okay. So what is osmosis? Lower concentration to higher concentration. Exactly opposite reverse osmosis, higher concentration to lower concentration. Okay. So seawater contains so many salts and the minerals are present, right? So these minerals and these salts, we we it is not useful for our health. So that's why we have to remove that one. Okay. So by using reverse osmosis, reverse osmosis. Okay. See, so both the compartments separated by a semi-permeable membrane. So the salt water contains many of the plenty of the salts and minerals. Okay. So this is two compartments are present. First one is first compartment contains brackish water or saline water or sea water, and the down compartment contains pure water. So which is converts into the water. Okay. So the sea water converts into the pure water. These two compartments separated by a permeable membrane, semi-permeable membrane. Okay. So the semi-permeable membrane consists some chemicals. They see cellulose acetate, polymeta, polymethacrylate, and polyamides. The semi-permeable membrane. Three chemicals are present. Those are cellulose acetate, polymethacrylate, and polyamides. Okay, so these three chemicals present into the semi-permeable membrane. So, what is the use of semi-permeable membrane? Why do we call it a semi-permeable membrane? We call it soon because it allows only, yes, it allows only certain molecules, not certain molecules. It allows only solvent. Okay, it allows only solvent. Solvent is nothing but water. Okay, pure water only. Okay, so are the water in this case, but does not allow the ions or the minerals or colloidal matter. Okay, yes. So 239, yes, correct. Allows only solvent. Okay, so it doesn't allows the ions, minerals, and colloidal matter present in the water. Okay, so when we apply pressure on the brackish water, when we apply pressure on the brackish water side, which is higher than the osmotic pressure, it is higher than the osmotic pressure. Osmotic pressure, it is a natural process. Okay, so we have to apply some more pressure on the brackish water, then only we get the pure water. Okay, so pressure, the water moves from the brackish water side or the sea water into the pure water compartment. It is called as RO water. RO means reverse osmosis. Students, please give me reply. Then only I understand. Okay, you are listening or not? RO means reverse osmosis. 239 and 231. These two members only listened, I think. Remaining all just simply connected. That's it. Okay. So this is about osmosis, reverse osmosis. I think understand, right? So once again, see, when two solutions, different concentrations are separated by semi-permeable membrane. So these solvent or water flows from region of lower concentration. This is called osmosis. The driving force of the process is called osmotic pressure. If a hydrostatic pressure is axis of osmotic pressure is applied on the higher concentration side, the solvent flow is reversed. That is, solvent flows lower concentration to higher concentration. So sorry, higher concentration side. So this is osmosis diagram. It is very, very important, and you have to draw the diagram in examinations also. Okay. So osmosis means lower concentration to solvent moves lower concentration to higher concentration. Okay. Exactly opposite in reverse osmosis, higher concentration to lower concentration. Solvent moves higher concentration side to lower concentration. Okay, through the semi-permeable membrane. Which chemicals we used in semi-permeable membrane? Which chemicals we used in semi-permeable membrane? Cellulose acetate, cellulose acetate, polymethaacrylate, and polyamides. Okay, these three chemicals were used in the semi-permeable membrane. Okay. Okay. So what are the advantages? So this process is called reverse osmosis. Thus in the process of reverse osmosis, pure water is separated polyamides, cellulose acetate, polyacrylate, and another one is polyamide. Okay. And chemical names also very, very important. Okay. Okay. This process is called reverse osmosis. Okay. So this is known as a super filtration. The membranes used or cellulose acetate, cellulose butyrate. So mostly we used these three chemicals only. Okay, advantages. So the process is simple, cheap, and reliable. Okay, advantages. The process is simple, cheap, and reliable, and it is not only removes the ionic salts but also the non-toxic colloidal matter and high molecular weight organic matter. Okay, it removes the salts. So it is also removes the non-toxic colloidal matter. Okay, non-toxic colloidal matter. Okay, so colloidal matter and high molecular weight organic matter. Although the installation cost is high, the maintenance cost is low. First, we have to invest that. Okay, so later the maintenance cost is less only. Okay, the membrane can be replaced in 3 to 4 minutes, and hence can get uninterrupted water supply also. Okay, so this membrane semi-permeable membrane is present into the RO. Okay, so that we have to fix the semi-permeable membrane. It takes only 3 to 4 minutes. Okay, so and hence can get uninterrupted water supply. Okay, So limitations and disadvantages. So limitations and disadvantages. The membrane cost is very high. Semi-permeable membrane is there, na? So that membrane cost is very high. Cost is very high, and membrane should withstand pressure of 20 to 100 atmosphere only. So the temperature also 20 to 100 atmospheric pressure only. Okay. So this is the lifetime of the membrane is high, can be replaced within few minutes, and it removes the ionic as well as non-ionic colloidal impurities due to low capital cost, simplicity, low operating. The process is used for converting seawater into drinking water. Okay. So this is about reverse osmosis process. Okay. And next topic is ion exchange. And next topic is ion exchange. Okay. So ion exchange, if you read the ion exchange, what do you get? Why we have to read? So you can able to define the ion exchange resin. You can able to define the ion exchange resin. You will able to describe the demineralization process or ion exchange process with a neat diagram. And you will be able to mention the advantages and limitations of demineralization process. Okay. So coming to the softening of water by ion exchange process. Ion exchange process. Okay. So these process, see, ion exchange. Ion exchange resins are cross-linked long-chain organic polymers. Okay. So ion exchange resins are cross-linked long-chain organic polymers, microporous in nature, carrying the exchangeable resins, exchangeable resins. Ion exchange resins are cross-linked long-chain organic polymers, microporous in nature, and carrying the exchangeable resins. Okay. So types of ion exchange resins. So in these ion exchange resins are two types. One is cation exchange resin and another one is anion exchange resin. Okay. So cation exchange resin carries acidic functional groups such as COOH, HSO4. Okay. Which are capable of exchanging their H plus ions. Cation ion exchange process contains two exchange resins. Okay. First one is cation exchange resin and another one is anion exchange resin. Okay. Cation exchange resins, it is capable for only acidic resins. It is exchanged. Okay. Carrying acidic functional groups such as COOH and HSO3. I mean sulfate groups, acidic and sulfate groups, which are capable of exchanging their H plus ions. Okay. So next one is anion exchange resin. Next one is anion exchange resin. It carries basic functional groups such as amines, quaternary ammonium, quaternary phosphonium, which on treatment with dilute sodium hydroxide are capable of exchanging their OH minus ions. Okay. So cation exchange resins, it is only capable exchange the acidic functional group. Cation acidic. Okay. Anion basic A B. Anion A basic B A B. Remember. So anion functional groups exchange the only basic functional groups. Those are ammonium. Okay. Ammonium and sodium hydroxide functional groups. So these basic functional groups such as amines NHT, quaternary ammonium and quaternary phosphonium. So which on treatment, which on treatment with dilute sodium hydroxide are capable of exchanging their OH minus ions. Okay, so demineralization process. Demineralization process. So this is the diagram for ion exchange. Okay, so this is a diagram for ion exchange. This process requires two towers or two columns. Ion exchange process requires two towers or two columns. Okay, so the first is a cation exchange column. This is a cation exchange column which is packed with the cation exchange resins capable of exchanging H plus ions. So these cation exchange resins capable of exchange the H plus ions. H plus ions. The anion exchange column, which is packed with the anion exchange resins. Anion exchange. Anion exchange column packed with anion exchange resins. So which is capable of OH minus ions. Okay, OH minus ions. So what is meant by raw water, hard water or raw water? Nothing but all the water sources collected in the reservoir. This water will contains all types of minerals in it. Okay, so hard water contains all types of minerals present in it. Okay, so for this example, let us consider the sorry. For this example, let us consider that raw water contains raw water contains calcium sulfate and sodium chloride in it. This hot water contains which chemicals present? Calcium sulfate, and another one is sodium chloride present in the hot water. Okay, so when these hot water or raw water passed through the cation exchange resin, the H plus ions present in the cation exchange. So here you can observe and you can assume. So this cation exchange contains H plus ions. Okay, H plus ions. This acid generator is dilute HCl. This acid regenerator contains dilute HCl, and alkaline regenerator contains NaOH. Okay, NaOH, here HCl and here NaOH. Okay, so when this raw water is passed through the cation exchange resin, the H plus ions H plus ions in the cation exchange resin get exchanged with the calcium and the sodium present in the water. So already cation exchanger contains H plus ions. Okay, so these H plus ions exchanged the sodium and calcium ions. Okay, calcium and sodium ions present in the hot water. Okay, so when you pass the hot water into the cation exchanger bed, already cation exchanger contains H plus ions. These H plus ions are converted calcium and sodium ions. Okay, present in the water. Now the water, after converting the water coming out from this column is free from cations. Okay, here sodium and calcium cations are removed in this cation exchanger. Okay, so free from cations. When this water is passed through the anion exchange column. So after free from cation exchange, this water passed through the anion exchanger. Okay, anion exchange column. The OH minus ions present in the anion exchange resin. Okay, already cation exchange bed contains H plus ions, and anion exchange bed contains OH minus ions. H plus and here OH minus ions are present. Okay, here cations are removed and here anions are removed. So finally what we get, cations and anions are removed. Okay, so demineralized water we get. Okay, we get the demineralized water. Okay, so present in the anion exchange resin get exchange with the sulfate molecules and chloride ions. Sulfate and here chloride ions. Here we remove the sodium and which chemicals, which element, which metals we can remove in cation exchange resin? Calcium and sodium. Calcium sulfate and sodium chloride. Okay, here hot water contains which chemicals, which chemicals present into the hot water? Calcium sulfate and sodium chloride. Okay, so cation exchanger removes the metals, means Ca plus and Na plus. Okay, these metals are removed in the cation exchanger. So, and remaining what elements are present, what compounds are present? Sulfate and chloride ions. So, these sulfate and chloride ions present into the water, these water passed into the anion exchanger. Okay, so next to anion exchanger, in the water coming out the SO4 ions present in the water coming out of these column is free from the both cation and anion. Okay, after coming the anion exchanger, it is the water free from the cation and anion exchanger. Okay, cation and anion free. Okay, free from both cations and anions. This water is called as demineralized water. This water is called as demineralized water. Okay, so as the minerals present in the water are removed, this is called as deionized water, as the cations and the anions present in. So the water is removed. So what will happen? What will happen? The H plus and OH minus ions get exchanged with cations and anions. Here H plus ions exchanged by cations, OH minus ions exchanged by anions. Okay, so that's why we call it as ion exchanger. Okay, so present in the water, we call such resins to be exhausted, that it is not capable of exhausting regenerate resins. The regenerate resins, the Cation exchange resins can be regenerated by passing dilute HCl. So here H plus ions and OH minus ions are present. After completion of this process, the cation exchange bed leaves left the H plus ions. Again, we have to fill the H plus ions, right? So that's why we have to inject the H plus ions. This is the injector, H plus ions. Okay. Regenerate resins, the Cation exchange resins can be regenerated by passing. Again, we have to regenerate it. Regenerated by passing the dilute HCl. When dilute HCl is passed through present in the dilute HCl get exhausted with the cations already present in the resin. When the dilute NaOH, sodium hydroxide, is passed through the anion exchange resin, The OH minus ions present in the dilute sodium hydroxide get exchanged with the anions present in the resin. Now the resins are ready for use again. Okay, so this is acid regenerator and alkaline regenerator. Okay. Okay. See, cation exchange process. Cation exchange process. So the H plus ions present in the cation exchange resin. The H plus ions present in the cation exchange resin get exchanged with the cations present in the raw water. Raw water. Raw water contains already, right? Calcium sulfate and sodium chloride. Okay. Not only these elements remain, so many also present. Sodium, potassium, calcium, magnesium. Okay. These metals also present. So these H plus ions means the H plus ions present in the cation exchange resin get exchanged with the cations present in the raw water such as sodium, potassium, calcium, and magnesium, etc. Okay. The water coming out of this column is free from cations. Okay. So, after we get the free cation water, free from cations. So, the reactions, all of you write down reactions are RH plus RH plus Na plus gives rise to RNA plus H plus. And next RH plus Ca plus 2 gives rise to R2Ca2 plus 2HCA 2H plus. So resins containing acidic functional group COOH and SO3H are capable of exchanging their H plus ions. 222, 310. Okay. And next, anion exchanger. Anion exchanger. OH minus ions present in the anion exchange resin get exchanged with the anions present in the raw water, such as chlorine, carbonate, bicarbonate, sulfate. Okay. So what are those cation exchange resins? Are sodium, potassium, calcium, magnesium. Remember, sodium, potassium, calcium, magnesium. These four are cation exchange resins. Okay. And anion exchanges are chlorine, carbonate, CO3 2 minus, bicarbonate, HCO3 2 minus, sulfate SO4 2 minus. Okay. These four are anion exchanges. The water coming out of this column is free from both cations and anions. Okay. So the H plus ions released in the cation exchange column and OH minus ions released in the anion exchange column combines from H plus and OH minus to forms the water molecule. Forms the water molecule. Okay. Next, regeneration. When all the exchangeable H plus and OH minus ions of the cation and anion exchange resin get exchanged with the cations and anions present in the water, the ion exchange resins are said to be exhausted. Then they are regenerated using dilute HCl and dilute NaOH solutions. Regeneration of cation exchange resin RNA plus H plus gives rise to RH plus and Na plus. Regeneration of anion exchange resin RCl plus OH minus gives rise to ROH minus Cl minus. So advantages: can attain demineralized water with hardness less than 2 ppm. ppm means parts per minute. Okay, this method can be used for both acidic and alkaline water. So both cations and anions can be removed. Advantages and limitations or disadvantages. This method is expensive as the ion exchange resins and the installation cost are high. The efficiency of the process is reduced if the water is turbid. The method is not suitable if heavy metals are present since regeneration.
ఇక్కడ ఏ క్యూబ్ కామన్ తీసాం, అప్పుడు ఆటోమేటికల్ గా ఇది కాస్త ఇలా మారిపోయింది, ఇది కాస్త 0 కాబట్టి ఇక్కడ 0 వచ్చేసింది. అప్పుడు మనకి వీఆర్ లెఫ్ట్ విత్ దిస్ థింగ్. హియర్ వీ హ్యావ్ టు సబ్స్టిట్యూట్ ఏ క్యూబ్ అండ్ ఏ స్క్వేర్. ఏ క్యూబ్ ఏ స్క్వేర్ యూ కెన్ ఫైండ్ హియర్. ఇక్కడ ఉన్నాయి, సబ్స్టిట్యూట్ చేసి. ఓకే, నౌ ఐఎమ్ ఎండింగ్ ద క్లాస్. విల్ మీట్ ఆన్ మండే. ఆ హోంవర్క్ చేస్తాం. థ్యాంక్ యూ ఆల్. థ్యాంక్స్ ఫర్ యువర్ లిజనింగ్.